Is the audio fine now? Okay. So it looks good, right? Okay, perfect. So, guys, the agenda of this particular session will be that we'll try to understand the importance of data, importance of AI in industries. We'll try to understand AI versus ML versus DA. Again, then we'll also try to understand where does data science fit into it. We'll talk about some of the good open source libraries, about cloud platforms, use of AI in various domains. So all this particular information we are going to actually discuss, and why exactly like AI, this is the right time to actually switch into AI because it is completely new. It is not there for longer period of time. Yes, it probably the concepts and the things are there, but with respect to practical implementation, many companies are implementing it nowadays a lot. So coming to the importance of data, guys. Now, if you go around 15 to 20 years back, the companies at that time, the major problem that they were facing, that how can they basically store data much more efficiently. So that was the problem at that specific time. Now what has happened is that if I just go 10 to 15 years back, they have come up with frameworks with respect to big data, Hadoop, and there are a lot of frameworks. If you are using some of the cloud platforms like AWS, Azure, or the Google Cloud Platform, so there are some frameworks which is actually given to you, and now the data has been efficiently stored. But still, now companies are thinking to utilize those data in such a way that so that to provide some wonderful user experience to the front end user, whoever are using actually your products. So if you take the success of Google, success of applications like Netflix, Amazon Prime, Amazon.in, so all these are perfect examples of using the data in the right kind of way. So even though from Cisco it has been mentioned that data is the new oil, and we can also begin with this fact. It says that at the beginning of 2020, the digital universe was estimated to consist of, so if
44
you
zettabytes of data. By 2025, approximately 463 exabytes, I'm not talking about hexa, exabytes would be created every 24 hours worldwide. So this is a huge amount of data, guys. And just understand, if we utilize this data in such a way that it'll be a wonderful, we'll be able to give some wonderful experience to the users who are using our products. Now, let's go ahead with the next slide. Here, I just really want to talk about AI versus ML versus DL versus data science. Now, you may have heard of various roles like AI engineer, ML engineer, vision developer, deep learning developer, or a data scientist. So, we'll just try to understand what exactly all these terminologies actually specify, and then we'll also be discussing about the Venn diagram on the right hand side, which is pretty much important to start. You need to know this before you start. Uh, if you want to really get into data science or AI, you know. So always remember, guys, in this domain, in this specific technology or work, AI is the final goal. Creating an AI application, so basically an intelligence application, is the final goal. You have to create that at the end of it, and you can use for that machine learning, deep learning, or data science. Now, if I really want to define AI, you can also say that AI is an application which do not require any human intervention to perform its particular job. It will be doing it by its own. It will not never require any human intervention. Now, coming to the machine learning, okay, some of the examples with respect to AI, you can see Netflix application, self-driving cars, and many more things. Okay. Now, if I consider about machine learning can be taken as a subset of AI, and it can also be treated that machine learning provides you stat tools to analyze the data, to create a lot of prediction models, to create clustering models, and many more things. So we basically say it as a predictive modeling kind of things. So what does machine learning do? Over there, they provide you stat tools. So if you consider with respect to any kind of machine learning algorithms, if I take an example of linear regression, logistic, or decision tree, at the end of the day, what you are actually getting over there, you are getting some stats tools in order to derive all those things and basically apply all those algorithms on the specific data, right? So machine learning is a subset of AI. In machine learning, you have various techniques. You have like supervised, unsupervised, and reinforcement. In the supervised technique, you'll be seeing that your data will be labeled and classified It can be two kinds of problems, that is regression and classification. Example of regression, I can say that calculating the price of the house price prediction, that can be taken example. Classification, whether the customer is going to buy the product or not. So all these kind of examples are already present. If I talk about unsupervised machine learning, we can consider an example of clustering models. So clustering models is one of the very good example. Some of the use cases that we have is called as customer segmentation and all. Uh, if I take the third type, that is reinforcement learning, right? Reinforcement learning can also be called as semi-supervised. Where the machine learns by itself by seeing the rewards that it actually gets. So if you know some example, recent news that had come, that like AlphaGo and all, they had actually beaten some human beings, who are very good at that specific game. So AI was able to beat them, right? Now again, now let's go to the next part, that is deep learning. So deep learning is not, it was just not invented right now. It is there from 1950s to 60s. And in 1980s, Jeffrey Hinton came with an amazing breakthrough, which is called as a backpropagation algorithm, right? Which is now being used extensively. Now, the main aim of the scientist was that can we develop some machines which can learn like how we human being learn, right? So that was the main aim behind coming up with deep learning concepts like neural networks and all, right? So that was the main thing. So here extensively neural networks are used, and again the main aim is basically to mimic the human brain. The machine should be able to mimic the human brain through the training of the neural networks, in short. So in deep learning, you basically have three different techniques. Again, these are the base techniques, and on top of it they can develop a lot of things. So the first technique is artificial neural network, the second technique is convolution neural network, and the third technique is recurrent neural network. So if I talk about artificial neural network, similar tabular kind of data, like how you solve in machine learning, create a predictive modeler, you can also do that with the help of ANN. Suppose your inputs are images and videos, at that time you can specifically use CNN. And the final part, which is RNN, which you have sequences of data, right? You can actually use recurrent neural network to do some of the tasks like forecasting, and a lot of NLP tasks can also be done by RNN itself. So again, if I consider about deep learning, it is a subset of machine learning. Now, if I come to the Venn diagrams, right? We have understood about AI, machine learning, and deep learning. Now, the problem comes with that, where does data science and big data actually follow, right? Where does it actually get placed, right? If you call yourself as a data scientist, guy, that basically means you need to work in all these particular fields, right? Machine learning, deep learning, computer vision, it may be statistics. You will be seeing that data science is a part of each and every Venn diagram that is present over there. So tomorrow, if you get a job with respect to data science, you really have to work in each and everything. You cannot say that I'm just a machine learning expertise, I'll just be solving only machine learning problem statements. It will not be like that. You really have to work with respect to everything. So then only you'll be able to call yourself as a data scientist. And that is why right now data scientist has a very good amount of salary. Okay. Now coming to this, as I explained to you about artificial intelligence over here, this is some of the description that I've actually given. Similarly, with respect to machine learning, I've actually explained to you what exactly it is, and probably I'll also be sharing this PPT with the Eduton team so that they can actually share it to you. Okay, now coming to this amazing things. Okay, and why? Suppose if you think that you are an experienced person, you have worked as a software engineer, if you have worked in IT companies, why it will become very easy for you to switch into data science? This is the main reason why I'm actually talking about, right? Now, if I see this particular diagram on the left hand side, guys, you can see that we have so many things. On the right hand side of this Venn diagram, we have maths and statistics, we have computer science, IT, we have domain business knowledge, right? So and right now in companies, right, if you know about Gartner survey, guys, it is said that more than 20 to 25 percentage of companies are using AI. They have started using AI, and probably in the upcoming 5 years, they are going to use it extensively. Now, if I take this example of this amazing diagram, why your experience counts. Suppose if you are a fresher, it is well and good. You can start preparing with respect to this. You need to have knowledge with respect to maths and statistics. You need to have knowledge with respect to computer science. You need to have good amount of domain or business knowledge. Now, what is this domain and business knowledge? First, I'll go with respect to experienced person. Then I'll come with respect to freshers. Now, I've heard a lot of question from experienced people. Krish, I've been working on this. I'm working as a software engineer. Uh, Basically in this specific programming language, can I move into data science, right? Yes, you can see that one part is computer science, right? Software development process. Now data science, whenever you are creating that application, that is an AI application, so you are actually following that software development life cycle. Okay, so it is pretty much important that if you have this all experience, it is well and good. Now for the people, for the experience, for the freshers, for the people who are in colleges, you should try to have a look in this specific way itself. Okay, just don't know, if I talk about data science, just don't think that you just have to create the models, right? Don't just stop over there. Instead, create it as a product completely from end to end, right? And one more point is, which is very very important, guys, you need to have a good amount of domain or business knowledge. You need to have, guys. Okay, and if I talk about freshers, or if I talk about people who are passed out, probably you'll get time to learn more and more use cases. As you do more and more use cases, you'll definitely learn all those domain or business knowledge that is required. But for an experienced person, whatever you did in your previous experience, make sure that you work on that too, because that will be used in data science some or the other way when you're working on that specific domain. And as I said, that maths and statistics are required. If I consider data, if you do anything with the data, in short, you'll be using techniques from statistics itself. They'll just not be equations, and you will be definitely able to relate those things. That is why it is pretty much important that you understand in that specific way. Okay, so I've taken this source from Wikipedia. You can see that I've written data science is an interdisciplinary field that uses scientific method, process, algorithms, and systems to extract knowledge. Okay, and there is also a concept of a data mining. Okay, so data mining is also a subset of data science. Okay, always remember that. And insights from any structural and unstructured data. Data science is related to data mining, machine learning, and big data. Data science is a concept of to unify statistics, data analysis, machine learning, domain knowledge, and their related methods in order to understand and analyze actual phenomena. So this small diagram really specifies the whole information. It provides a lot of information with respect to data science. As I told you guys, a type of machine learning, we have supervised, unsupervised, and reinforcement. In supervised, we have to really do a lot of kind of prediction models. It can be a regression or classification problems. In case of unsupervised, we need to identify clusters. Some of the better examples is like you can consider anomalies detection and all. So that comes in unsupervised machine learning algorithm. You have customer segmentation. Suppose you want to trigger some kind of ads to a specific set of customers. How do you cluster those customers and all these things? Reinforcement, in short, says that you have to learn from your mistakes. I hope everybody has seen a small kid who does not know how to work, but slowly seeing his environment, seeing others, he will be learning those things. He'll fall most number of times, but again he'll learn from that, and he'll actually will be able to complete that specific task, right? So this was in short about this one. If I take about supervised machine learning, these are some of the examples. You can see this is a label data. Labels are like hexagon, triangle, and square. If we provide it to the model, if we do the prediction from the test data, we will be getting the square and triangle, right? So this is a simple classification problem with respect to label data. Similarly, in case of unsupervised machine learning, you can see that this is your input raw data, right? And then you're actually passing it through the interpretation of the model, and finally you'll be able to see this kind of clustered data. Okay, so this is one example. If I talk about reinforcement learning, you can see that based on the environment, this agent over there will be doing some kind of task, and based on that task, he may be getting rewarded or he may not be getting rewarded. If he is getting rewarded, that basically means he's going in the right path. If he's not getting rewarded, that is just like a failure. So from the next time, he'll not follow that path. Instead, he'll follow the path where he'll be getting more and more number of rewards, right? So this is also a very very good thing that is going on, guys. A lot of research are going on in this. But if I talk about supervised and unsupervised, a lot of problem statements are there extensively in even in many companies as such. Okay. Now, talking about the various algorithms in machine learning, let it be supervised, unsupervised, and reinforcement. So, as I said, in supervised, you have regression and classification problem. If I talk about regression, there is regression algorithms like linear regression, polynomial regression. Then if I talk about decision tree has both the techniques, both the algorithms like decision tree classifier, decision tree regressor. Similarly, you have with respect to random forest classifier, random forest regressor, and here you can see all the classification algorithms specified. You also have algorithms like XGBoost regressor, XGBoost classifier, ADA boost regressor, ADA boost classifier, gradient boosting regressor, gradient boosting classifier. So all these kind of algorithms are already present in the scaler. Okay, and coming to this unsupervised, I have already told you clustering algorithm can also be performed with the help of PCA, that is principal component analysis, K-means, hierarchical mean clustering, and you also have two techniques like a priori and FP growth. You also have a concept which is called as hidden Markov model. Okay, in reinforcement, you can have various techniques which I did not mention over here, but you have also over there. In short, you will just try to write your own codes, and there are some amazing frameworks which will help you to create some reinforcement algorithms too, right? Now, this is pretty much important, guys. So, with respect to the open source libraries used in ML and DL, I hope everybody's familiar with this. These all are open source, amazing to use. You have scikit-learn, Keras, TensorFlow. If you don't know about TensorFlow, guys, before TensorFlow was not given as an open source, Google used to use that, but now they have actually given, some years back, they have actually given this as an open source. Keras is a wrapper on top of the TensorFlow. You have Theano, you have PyTorch. PyTorch is an amazing library which has come recently, I think on the last year by Facebook. You have Pandas, NumPy, NLTK, Spark, and many more things, right? You can also use Big Data Hadoop over here, right? So all these libraries, you think if you have actually started preparing for data science, I think you have extensively used this. But out of this, my favorite are Keras, TensorFlow, and PyTorch, because of which I'm able to do a whole lot of work with respect to deep learning. Okay, now cloud platforms. If I talk about cloud platforms, if you don't know about cloud platforms, guys, as I said, that data science is not only about model building. You have to include software engineering also over there, and based on that, you also have to focus on developing a product, right? A software product. It may be an application, it may be something else, right? But one important factor is that that model that you will be training, right? You also need to do the deployment. So most of the MNCs, right? Most of the MNCs and startups, right? They use Microsoft Azure, AWS, and Google Cloud Platform. That is what I have actually seen from my past experience. But this two platforms, that is Heroku and Cloud Foundry, has also been used by many of the companies, right? If I take an example of Microsoft Azure, AWS, and Google Cloud Platform, these are infrastructure as a service. If I take an example of Heroku, it is basically platform as a service. So, what is the difference between infrastructure and a platform? In infrastructure, they will be giving you the whole server itself. You have to do the installation, you have to do the setup of all the libraries over there. Whereas in the case of platform as a service, you don't have to do all those things. And many people are also saying that Heroku is built on top of AWS, right? So this is actually provided as a platform. They'll be giving you the machine. You have to just provide one requirement.txt file. They'll do the automatic installation of all the libraries that you have actually provided. But if you really want to focus on this three, that is Microsoft Azure, AWS, and Google Cloud Platform. These are some amazing platforms. AWS has extensive number of services. Even I have also tried using Google Cloud Platform. It is pretty much amazing. Okay. So this was about the cloud platforms used and specifically for deployment. You also have something like CI/CD pipelines, which is also called as continuous integration, continuous development. There is one recent tool that has come that is called as Circle CI. So this is also an amazing tool to actually create CI/CD pipelines, which is very, very good. The other tool I think which is many people are familiar with is basically Jenkins. You can also use Jenkins for the CI/CD pipelines. Okay. So, use of AI in various domains. So, I've mentioned over here some amazing domains like e-commerce, retail, traveling domain, sales, finance, social media platform, healthcare, banking, cybersecurity, and logistic. If in the right hand you see, guys, if you take an example of e-commerce, that is Amazon.in is one example. You have traveling domains like Make My Trip. You have healthcare. In healthcare, obviously, different types of disease detection, disease prediction, everything is there. Social media platform, You have image tagging, image classification, and many more in Facebook itself, right? If I talk about cyber security, so recently I think you have seen a lot of data were leaked through some or the other way. So that also we can actually prevent by using AI. On the right hand side, this particular diagram says that what all techniques we use machine learning, neural networks, image recognition, prediction, natural language processing, knowledge representation, autonomics, virtual agents is an amazing use case of chatbots, guys. The chatbot, now if you go and see in every other site, you'll be able to see this kind of chatbots being getting used, right? Deep learning techniques, speech recognition analytics. So all these things, techniques have been included in this AI domain. Finally, your main goal is to create an AI application. Now, I have also mentioned some of the use cases over here with respect to supervised. You can see the regression problem statement, population growth prediction, estimated life expectancy, market forecasting, weather forecasting, advertising popularity prediction, diagnostic, customer retention, identity fraud detection, image classification. Similarly, you have with respect to dimensionality reduction, big data visualization, meaningful compression. You have clustering like recommender systems, targeted marketing, customer segmentation, and even though reinforcement example is given like game AI, robot navigation, skill acquisition, and real-time decisions. So these were some of the example of some use cases. So guys, you can also connect me through LinkedIn. So if you have any other queries, you can ask me over there. And yes, if I get time, I'll definitely give you a reply. So this was all from my end uh, about the basic things about data science and the other things which will be definitely important for you all to see this, right? It is very, very important if you really want to get into data science. So yes, this was all from my side. Thank you. I think you can continue. Thank you. Yeah.